Next up, we have Pegah Askari, who is a third-year biomedical engineering student who is also in the Advanced Neuroscience Imaging Research Lab, and her talk is entitled Towards Automatic Labeling and Processing of Clinical MEG.
We have an amazing brain. Our brain is a piece of art. It does so many wonderful things. But sometimes it just doesn't work as we would like it to work. In people living with epilepsy, the neuron can experience a sudden burst of intense electrical activity, causing recurrent and spontaneous seizure. Epilepsy affects more than 50 million individuals worldwide, and even with the great progress in science, there are still 30% of patients who do not respond to medication, and they need surgery to remove the part of the brain that's causing the epilepsy. So it is important to correctly find the location of this epileptogenic zones while also saving the functional area of the brain for a successful surgery outcome. So, so it is important to find the correct location. So one of the important biomarkers to correctly find the epileptogenic zone is the spikes, and this spikes can be measured with the magnetoencephalography known as MEG. MEG is a non-invasive imaging technique that can measure the magnetic fields induced by electric currents in the brain. The spike detection is done by visually scanning the MEG signals by a trained neurophysiologist. And this spike detection is manually possible, but it's like finding a needle in a haystack, and it's a subjective method. So in my research, my goal is to develop an machine learning algorithm that will be able to detect and automatically the spikes and to automatically detect the spikes to make this process and the clinical practices more automatic and efficiently. So my code takes the clinical resting state MEG signal as an input and then will provide us with the output, which is the spike time points. Then we are using the clinical resting state MEG signals for as an input to our machine learning, and then we train our network based on that to detect and predict the labels for the spikes. So we know that the reading the MEG signals and finding the spikes could be a time-consuming and laborious task, but I'm excited about the prospect of my research that would be able to help us in the future to do this process more automatically and efficiently. Thank you.